Okay, now we're going to do an example problem where we solve a triangle that is a side-side angle. So I'll read the problem to you. It says, let triangle ABC be a triangle with B equal to 10, side C equal to 7, and the measure of angle C equal to 36 degrees. Now I know it's side-side angle and not side angle side because if it were side angle side, I can draw a triangle real quick. A, B, C, little a, little b, little c. So if it were side angle side, you would know A, B, and angle C, or A, C, and angle B. In each case, you would have 3 different letters for the things you know. But we know B, C, and angle C. So if we go around the triangle, that's side, side, angle, as opposed to side, angle, side. The angle's not in between the sides, it's across from one of the sides. So this is SSA. Because this angle is across from one of this, it's not in between the 2 sides. So our goal is to solve all possible triangles, if there are any, because we looked earlier that when we looked at the general case, sometimes there's no triangle. So we're going to draw the picture for this first to get a handle on it. And drawing the picture with the angle in the bottom left corner will give us the most intuitive understanding of this. And that was the same reason why I chose to draw the angle in the bottom left corner earlier, so we can think of the side we don't know as the base. So we're going to draw the side we don't know as the base, which would be side A. This is my angle C, which we do know as 36 degrees. And then the other important place is where to put B. Again, yeah, this is the side we don't know, so this must be B, which is equal to 10 units. So there's B. And then this is 7, C equals 7. Okay, so now we have to determine, first and foremost, if it can even be a triangle, and if there's multiple triangles, or if there's only one triangle. So let's draw the height down, and if we remember how we found the height was by looking at this right triangle with 36 degrees and 10 as the hypotenuse, so that says that the height is equal to 10 sine 36 degrees, which calculated it earlier is roughly 5.87. 10 sine 36. 5.88, yeah. Roughly 5.88. And so this length is longer than the height, which means it will reach. But it's shorter than this side, which means it's going to reach and create 2 triangles. So this is the other possible triangle that's got the same side-side angle configuration. So let's label each of these points. Let's say this is B1, and the other triangle is B2. And we're going to solve each triangle. We're going to solve each possible triangle. Okay, so for the triangle where B1 is acute, we can determine that one first. Sine of 36 degrees over 7 equals sine B1 over 10 by the law of sines. We multiply both sides by 10, multiply both sides by 10, and that says that the sine of B equals 10 sine 36 degrees over 7. So then measure of angle B is equal to the inverse sine of 10 sine 36 over 7, which is roughly calculated this one, 57.1 degrees. So here's 57.1 degrees. So let's also find the measure of angle B2 while we're at it, because it's actually staring us in the face. This one and this one are congruent because of the isosceles triangle right here. So this is also 57.1. Well, I'll draw, the blue triangle is one of the ones we're trying to solve, and then the green triangle, because there's multiple triangles in this picture, is the other possible triangle with 7, 10, and 36 degrees. So to find the green angle here, we simply take the other answer for the angle B, which is the one that's 180 minus this one. So this really is angle B1. B1. So that says that the measure of angle B2 equals 180 minus the measure of angle B1, which is roughly 122.9 degrees. So this is 122.9 degrees. And two possible triangles in this case, one in which the angle for B is obtuse, one in which the angle for B is acute. Okay, so let's draw the blue one a little bit bigger over to the side. Yeah, B1, so it's measure of angle B2. And this one is measure angle B1. Okay. So from here we have 57.1. This one is 36 degrees. This is 10. This is 7. So it's not too hard to solve the triangle from here. We note that these two plus angle C, or angle A in this case, this is C, this is A, this is B.
Good morning, Franklin. If you haven't started to do so already, please tune in to QTV. Have a great Friday.
So these two angles plus angle A must add up to 180 degrees. So we can do 180 minus 36 minus 57.1 is equal to the measure of angle A. And we can calculate that. That's 86.9 degrees. So this would be 86.9. And then we'd use the law of sines to find out this side, noting that sine of 86.9 over A equals sine of 36 over 7, and solving for A in this case. So we already know how to solve this triangle, because we basically have angle side once you've found this angle. Likewise for the other case, the green case. So I won't find side length A because you already know how to do that. So in the green case, our triangle, which looks like this, with this angle being 122.9 degrees, this being 10, this being 7, and this one being 36 degrees. Hopefully you see what we're going to do. We're going to add these two, subtract from 180 to find the measure of angle A, and from there find side A using the law of sines again. Again, I won't go through those steps all the way, but finding angle A is easy because the angles add up to 180, and then finding this side is the same as finding this side from this triangle. You do sine of this angle over this side equals sine of 36 over 7, and solve for the missing side. Cool. So from here we have the two possible triangles, and we're able to solve them.